Good morning to one and all. Myself Dr. Ramgopal from MLR Institute of Technology, Department of Mathematics. And today's session is on testing of hypothesis 2. The test of hypothesis concerning one mean small samples. Let us recall the previous presentation. In the previous presentations, we have discussed the testing of hypothesis concerning, for example, one mean large sample, two means large sample. Now coming to today, the testing of hypothesis concerning means for small samples will be discussed, and also the particular case. Now coming to testing of hypothesis concerning means, there are two types. One is for large samples and the other is for small samples, and large samples we have completed in the previous sessions. So testing of hypothesis concerning small samples for one mean and testing of hypothesis concerning small samples for two means. And now in the case of expensive populations such as satellites, aeroplanes, nuclear reactors, supercomputers, etc., the investigation of characteristics of large samples is uneconomical, even impracticable also. In such cases, we consider the small samples, that is n less than 30. So now coming to testing of hypothesis concerning one mean for small samples, and the procedure of testing of hypothesis is as it is from null hypothesis, alternative hypothesis, level of significance, critical region, test statistic, which is the calculation part, and finally the decision. Now in one mean small sample problems, since we are dealing with one population, one sample and one mean for population and sample, the null hypothesis will be mu equal to mu naught. The given, this mu naught is the given population mean. So mu equal to mu naught is the null hypothesis, and we test this null hypothesis against three types of alternative hypothesis, either mu less than mu naught or mu greater than mu naught or mu not equal to mu naught. As we know, there are three types of alternative hypothesis, and we consider one of these three forms. So we test the null hypothesis against the alternative hypothesis, either less than type or greater than type or not equal to type, and the level of significance as usual alternative, otherwise accept null hypothesis. That depends on the calculated value. If the calculated value is negative, compare with this negative condition, and if the calculated value is positive, then compare with this positive condition. And coming to the fifth, values or the data follows the t distribution with nu equal to n minus 1 degrees of freedom. The t distribution table was constructed for different values of nu, the degrees of freedom, and here the calculation formula is given by t calculated is x bar minus mu by s by root n, where x bar is the mean of the sample, mu mean of the population, s standard deviation of sample, n the size of the sample. This notation also we have discussed in the previous sessions. So here the calculated value is given by x bar minus mu by s by root n, where s is the standard deviation of the given sample. For example, if s is not given, we can replace it by the standard deviation of population denoted by sigma. If s is not given, we can replace it by sigma, and finally we take the decision by comparing the calculated value with the tabular value. Let us discuss one example on one mean small sample problem. An ambulance service company claims that on an average it takes 20 minutes between a call for an ambulance and the patient's arrival at the hospital. So again I repeat, an ambulance service company claims that. So here the company's claim is given as on an average it takes 20 minutes between a call for an ambulance and the patient's arrival at the hospital, and here it is clearly mentioned average. So that means this problem comes under means, particularly one mean, and here in 6 calls. So the sample size is 6, so which is less than 30, hence it is small sample. So, this problem comes under one mean small sample. In 6 calls, the time taken are given. First call 27 minutes, second call 18 minutes, third 26, etc. The data is given. Can the company's claim be accepted at 5% level of significance? That is the question. So, a claim is given by the company. On an average, it takes 20 minutes, and a data regarding 6 calls is given. Since the sample is small, here in some problems the data will be given. We need to calculate the mean of this sample, standard deviation of this sample, and then we test the hypothesis whether to accept the company's claim or not. Whereas in the case of large sample problems, since the sample size is large, greater than 30, the mean and standard deviation of the sample will be given in the problem itself. In the case of small samples, we need to calculate if the data is given. Now, coming to the solution. So, first write the given data. What is the company's claim? On an average, it takes 20 minutes. This is the general information regarding the company. That means it is the mean of the population, mu equal to 20, and we need to test this claim using a sample of 6 calls. That means the size of the sample n equal to 6. Then the sample data is given 27, 18, etc. So, first we need to find the mean of the sample. The mean of the sample x bar is sigma x by n. That means sum of all the individual values divided by the size of the sample. If we calculate this 27 plus 18 plus so on plus last value is 32 divided by 6, we will get x bar as 23. Similarly, standard deviation of sample. What is the standard deviation of sample? The positive square root of variance, so denoted by s. So, first if you calculate s square, we can calculate the square root of that s, and to find the variance of the sample denoted by s square, the formula is sigma xi minus x bar whole square by n minus 1. Since we are calculating the variance for a sample, in the denominator we use n minus 1, and the formula to find the variance of the population in the denominator we use the size of the population, capital N itself. So, here from each individual 27 minus x bar, the mean of the sample is 23, 27 minus 23 whole square plus 18 minus 23 whole square and so on. So, the variance calculates the difference between the actual value with about the mean of that sample. So, sum of the squares of such values divided by n minus 1 gives the variance. If we substitute these values in this formula, we will get the variance as 40.8, and the standard deviation s is the positive square root of variance. So, root 40.8, which results 6.38748. Since the sample is small and the data is given, we have calculated the mean of the sample and standard deviation of the sample. If these values are given in the problem itself, directly we can go to the test of hypothesis. Now, coming to the test of hypothesis, we need to test the claim of the company whether to accept it or to reject it, and the company's claim is on an average it takes 20 minutes. So, mu equal to 20, that is the null hypothesis, and we need to test this against the alternative hypothesis. As we know, there are 3 types of alternative hypothesis: less than, greater than, not equal to. For example, if we consider not equal to type, simply we can say it does not take 20 minutes. Can we reject the claim of the company if we consider not equal to type? No, it is not possible. Similarly, the company claims that on an average it takes 20 minutes. Within 20 minutes they will reach to the hospital. If we consider the alternative hypothesis as mu less than 20, what does it mean? That means they can reach the patient to the hospital within 20 minutes, less than 20 minutes, that means 15 minutes or 18 minutes. can we reject the null hypothesis or the company's claim if we consider less than type? Again not possible. So, which is wrong? To reject the null hypothesis, we have to show that on an average it takes more than 20 minutes between a call and to reach the patient to hospital. So, that is why here we consider the alternative hypothesis as greater than type, mu greater than 20. If they take more than 20 minutes, then we can reject the null hypothesis, and the level of significance is given as 0.05, 5% level of significance, and the critical region, the conditions are similar that we have used in the case of jet test for large samples. So, reject H naught if T calculated is, since it is greater than type, T calculated is greater than T alpha. For alpha equal to 5%, that is 0.05, and the size of the sample n is 6, therefore, nu is n minus 1, 5 degrees of freedom. T alpha value is given by T 0.05 is 2.015. So, this is the tabular value that we can find from the T distribution table. Now, coming to the fifth step, we need to compute the calculated value here using the test statistic. T calculated is x bar minus mu by s by root n. So, we have the values. So, T calculated x bar that we have calculated as 23 minus given 20 divided by standard deviation, also we have calculated 6.38748 divided by under root n, 6 calls, n equal to 6. So, after finding the value of this calculator, T calculated, we got 1.15. Now, let us compare these two values. So, the decision, since the calculated value 1.15 is less than the tabular value 2.015. So, T calculated is less than T alpha. The problem is of greater than type, and the condition is if T calculated is more than the tabular value we can reject, but finally, we have obtained T calculated is less than the tabular value. Therefore, accept the null hypothesis. If our calculated value is more than the tabular value, we can reject the null hypothesis, but what we have obtained here, the calculated value is lesser than that of tabular value. Hence, accept the null hypothesis, that is accept claim of the company. Hence, on an average it takes 20 minutes. We are accepting the company's claim. So, using the testing of hypothesis, the procedure of testing of hypothesis, we can test the manufacturer's claim or company's claim also. Similarly, let us discuss one more problem on one mean small sample. Here the problem is in 1950 in India the mean life expectancy was 50 years. If the life expectancies from a random sample of 11 persons are given, so a random sample of 11 persons, so n equal to 11, which is small sample. Here the values are given 58.2, 56.2, 6, 54.2 and so on, 11 values are given. Does it confirm the expected view at 1% level of significance? Expected view means it is given already the population mean or the mean life expectancy is 50. So, given the population mean mu equal to 50 years and size of the sample is taken 11 and the data is given. So, we need to calculate the mean of the sample having 11 elements. So, sigma x by n 58.2 plus so on plus 57, sum of 11 values divided by 11. So, which will be equal to 54.41. Similarly, the variance S square we can calculate using the formula sigma xi minus x bar whole square by n minus 1, and the standard deviation of the sample S is the positive square root of variance, and which results in the form 4.859. So, we have obtained x bar 54.41, S 4.859, the size of the sample n is 11. So that we can go for the test of hypothesis, and the test is as follows. The null hypothesis H naught, it is given the mean life expectancy was 50 years, so mu equal to 50. Alternative hypothesis, the question is, does it confirm the expected view or not? Simply we need to check whether the average life expectancy was 50 years or not, basing on the given sample. So we consider the alternative hypothesis is mu not equal to 50, not equal to type problem. That means two-tailed test. The critical region lies on both tails of the probability distribution curve. Alpha by 2 region lies on left side, alpha by 2 region lies on right side. Now level of significance is given 1%, which is 0.01, and the critical region in not equal to type, we have to compare that calculated value and tabular values. If the calculated value is negative, compare with the negative tabular value. If it is positive, compare with the positive tabular value. So reject H naught if T calculated is less than minus T alpha by 2, or T calculated is greater than T alpha by 2, or T calculated is less than minus T alpha by 2, or T calculated is greater than T alpha by 2. These are the conditions to reject the null hypothesis basing on alternative hypothesis less than type, greater than type, not equal to type. And in the present problem, the alternative hypothesis is of not equal to type. So we consider the last condition, reject the null hypothesis if T calculated is less than minus T alpha by 2, or T calculated value is greater than T alpha by 2. Here we consider alpha by 2. Given alpha is 0.01, so alpha by 2 we can calculate 0.05, and now for mu equal to n minus 1, 11 minus 1, which is 10 degrees of freedom, from T distribution table we can calculate this T alpha by 2. From T distribution table it is 3.16. Use the T distribution table for 10 degrees of freedom, and alpha by 2 is 0.005. The T alpha by 2 value is 3.169. Now coming to the calculation part, here the T calculated is given by x bar. So we have calculated x bar as 54.41 minus mu is 50 divided by standard deviation. Also we have calculated 4.859 divided by root 11, and the final answer will be 3.01. Now this is the calculated value and this is the tabular value. By comparing these two and using the step number 4, critical region, use the condition to reject the null hypothesis. And now the decision is, since 3.01 and 3.169 both are positive values, 3.01 is less than 3.169, that means T calculated is less than T alpha by 2, but for positive condition we must get greater than. If T calculated is greater than T alpha by 2, we reject the null hypothesis, but here we got the result completely in the reverse manner. T calculated is less than T alpha by 2 for positive value. Therefore we cannot reject the null hypothesis. That implies accept the alternative hypothesis. If we are rejecting the null hypothesis, we have to accept the alternative hypothesis. But here T calculated is less than T alpha by 2, so we have to accept H naught. That means we cannot reject the null hypothesis. So we accept the null hypothesis that the mean life expectancy was 50 years in 1950. And coming to the summary of today's session, in today's session we have discussed the test of hypothesis concerning one mean for small samples. In one mean small samples we use T distribution, and we calculate the tabular value of T for nu equal to n minus 1 degrees of freedom and using T distribution table, and the test statistic follows T distribution given by x bar minus mu by s by root n. and we have discussed 2 problems on testing of hypothesis concerning one mean for small samples also. In the next session, we will discuss the test of hypothesis concerning 2 means for small sample. And thank you very much.